This video is a second example problem where we find the product of inertia for a composite area. So we're going to use the parallel axis theorem for the product of inertia. And this example includes a right triangle and a quarter circle. And so we have to figure out what their proper sign is at their particular orientation. So this is a horizontal segment. It's a rectangle. There's a quarter circle here at this orientation. And there's a right triangle down here at that orientation. So let's look up their formulas and make sure what's going on. So neither is at the origin, so we can't use an origin formula. So a quarter circle at that orientation is a positive 0.01647 r to the fourth. And so for our product of inertia, we have a positive 0.0647 r to the fourth, 2 to the fourth. That's positive. And for our right, we're skipping the Ix and Iy because we're focusing on product of inertia right now. So a triangle at this orientation, where its right corner is at the upper right, that's this one down here at the lower left, and that's a negative sign for this guy. And so his centroidal product of inertia will be negative 1/72 b squared h squared. And that's what we did. That's a negative for our triangle. Okay? So for the rectangle, because his centroid is located at the origin, his dx and dy are both 0. Plus, since it's a rectangle, his I bar is 0. So the entire term for the rectangle is 0 plus 0. For our quarter circle, his I bar xy is positive this term. His area is pi r squared over 4, so pi times 2 squared over 4. The dx measured from the y-axis to his centroid is 1 plus 0.8488. So 0.8488 is equal to 4r over 3 pi. So 4 times 2 divided by 3 pi is 0.8488. So 1 plus that, so it's a negative 1.8488 is his dx. And his dy is 0.5 plus 0.8488. So when you go from the x-axis up to the centroid, it's 0.5 for half of this beam plus 0.8488. And that distance is 1.3488. And it's positive because you're going from the x-axis up. So those are the terms for the quarter circle. For the triangle, again, his I bar xy is negative 1/72 b squared h squared, which is 2 squared times 2 squared. The area of the triangle is 1/2 base times height. That's 1/2 2 times 2. His centroid is 0.667. And so his dy is 0.5 plus 0.667 in the negative direction. And so that dy is negative 1.167. His dx is 3 minus 0.667, which is 2.33, positive 2.33 for his dx. So positive 2.33. So our product of inertia for this shape is 0 minus 7.57 minus 5.67. So it's minus 13.2 inches to the fourth. And again, his area is kind of along a diagonal that goes from quadrant 2 down to quadrant 4. So you expect him to have a negative IXY, and he does.